Chapter 2, Section 3, we are looking at proofs. This is our introduction to proofs. We have three types of proofs. You can write paragraph proofs, where you actually write out a whole paragraph. You can use flowcharts, or you can use two-column proofs. And we're going to focus on one type, the two-column proofs. Proofs usually have multiple steps, but the form always stays the same. And this is kind of what a two-column proof looks like. You're going to have a given and something to prove. And then sometimes there's a diagram here. First step is the easiest step in all of geometry. You just recopy the given and write given. The last step is always what you're trying to prove, and there's going to be a number of steps in between, and we're going to write justifications. So our first one, our given, is 3x plus 8 equals 15. Solving this, you're going to subtract 8 from both sides, and then you get 3x equals 7. So from the first step to the second step, we used the subtraction property of equality. And some of you might call the addition property of equality, because you add a negative. And then from here you divide both sides by 3, and x equals 2.3 repeating. And to get from this step to this step, you used the division property of equality. Example 2, you always start with what you were given and write down your given. And these first couple are algebraic proofs. Our first step would be to distribute. 2x minus 6 equals 16, which is the distributive property. From there you would add 6 to both sides, and you would have 2x equals 22, and we added to both sides, so that is the addition property of equality. And then you divide both sides by 2, and you have x equals 11, and that is the division property of equality. Now those first two are algebraic proofs. On the next page we have some geometric proofs, and we need to use some of the geometry that we've learned. Starts out, B is the midpoint of AC, and that is our given. And they also give us that AB is equal to EF, and I like to mark up in my picture. Those two things are equal. Well, they gave us this big hint here with midpoint. We have to be able to say something with that word midpoint, and that is that AB is congruent to BC, and that is by our definition of midpoint. Well, now we have AB equal to BC, AB equal to EF, so this can go take the place of that one, and you have BC congruent to EF by substitution. And we're going to use substitution a lot. Example 4, we start with our given, and that is red. The measure of angle CBD is congruent to the measure of angle D. So in our picture, CBD is equal to angle D. That is our given. And we're trying to get this angle over here, I'm going to put a question mark there, equal. And they don't have any nice hints, no nice midpoint, no great hint in our given. So this time we need to look at our picture, and we're trying to get something with this angle. So there is a relationship between these two. These are vertical angles. So we can say ABE is congruent to CBD by the vertical angle theorem. And then both of these equal CBD. So we can say the measure of angle ABE is congruent to the measure of angle D by substitution. And example 5, we are given the measure of angle 4 is congruent to the measure of angle 1 as our given. So I'm going to mark that in my picture. Again, we have no nice hints, nothing else going on, so we have to figure out some things from our picture. Well, we've got a hint here, vertical angles. We can say angle 1 is congruent to angle 2. Well, if angle 1 is congruent to angle 2 and angle 1 is congruent to angle 4, then we can say the measure of angle 4 is congruent to the measure of angle 2, and that again is by substitution. So we used vertical angles, and then we had substitution. And sometimes you'll notice in step 2, I just wrote angle 1 is congruent to angle 2. Measure of angle 1 is congruent to the measure of angle 2. Very, very similar. If you don't know the angle measure, a lot of times you put this little measure thing in front of it.